All right, so yesterday we started looking at sine and cosine. We graphed a phase shift, which really, what's a simpler way of explaining which way a phase shift moves?
Horizontally?
Moves horizontally, yep. So we shifted left and we shifted right. Today, we're going to look at another kind of shift. Okay, we will look at a vertical shift, and we're going to look at our first stretch. Okay? But everything we do today is going to be vertical, whether we stretch it vertically. This is what a vertical stretch would look like.
So we're stretching, not moving this time?
The first one, yeah. So this would be a vertical stretch. It just takes the graph and stretches it vertical. And the other transformation we're going to look at is a shift, which takes this and just moves it either up or down. So that one is not a stretch. So we're going to do one shift, one stretch. All right, so the first thing is when we are talking about stretching a wave taller or compressing it shorter, we're basically going to be changing the height of the wave. So when I talk about the height, what's the word we're going to use? It's called the amplitude. Okay, the amplitude is the height of the wave. Sine wave or cosine wave. When you measure the amplitude, it's the distance from the center up to the top. Okay, that's the amplitude. You can also measure it from the center down. It should be symmetrical. But one thing we want to remember about amplitude is it's a height. What kind of number does height always have to be?
Positive.
Always has to be positive. Okay? So when you are asked to find the amplitude of a function, which does not involve graphing, it's just writing a number, you would never write a negative number for the amplitude. Think of it, it's a distance from here to here. There's no negative distances. All right, any question on what amplitude is? All right, so what does an amplitude change look like? Well, what kind of arithmetic did we do yesterday inside the parentheses?
Positive, negative?
Which was
Addition and subtraction.
adding or subtracting.
So are we doing multiplication or division?
Yeah, multiplication. Okay, so whenever you add or subtract, that is always a shift. When you multiply, it is a stretch. And what we're going to be doing is multiplying by a number in front. This is not inside the parentheses. Okay, so this is outside the parentheses. So outside the parentheses means it's vertical. Multiplication means it is a stretch.
So if it's outside the parentheses, it's stretch?
If it's outside the parentheses, it's always something vertical. Could be a stretch or a shift. Depends if you're doing multiplication or division. Okay, so let me just write that down. So where you're doing the operation, inside or outside the parentheses, this tells you if it's either a horizontal or a vertical. The what you're doing, okay, are you doing addition or subtraction, or are you doing multiplication? That tells you if it's a stretch or if it's a shift. So you got to look for where you're doing and then look at what you're doing. Okay, so where, it's on the outside. What is it? Multiplication. That means it's a vertical stretch.
So multiplication if it's a stretch?
Yep. So here's a couple examples. These are all either stretching or compressing. Okay? Let's just graph one so we can see what happens. If I graph sine x and then I graph, let's say, I don't know, 4 sine x. Do you think the 4 is going to make the graph stretch taller or
Taller.
compress? Yeah, it does get taller. Okay, so that's the original. Notice it's between 1 and -1. And when I put a 4 in front, now it's between 4 and -4. Okay, so it took that blue wave and it made the amplitude 4 times as much. That's a vertical stretch. What do you think a negative would do?
Wouldn't it just do the same thing? Because I think it'd make it go up to -4 and up to 4.
It's still going to stay between -4 and 4, yes. But the red and the black graphs are going to look different because one has a 4, one has a -4. Anyone have a
flip?
It's going to flip it, yeah. So when you put in a -4, look at the red and the black one, it causes them to flip.
So that just means it goes to the -4 first rather than going to the 4 first?
It does the opposite of whatever it did originally.
Okay.
Yeah. So negative causes the graph to flip. One more one we can look at. Let's look at like
That'd be smaller, right?
0.5. Yep. So if we do 0.5 sine x, let's actually put in 0.5 and do zoom 7. So what do we think is going to happen this time?
It's going to go half as much.
Yeah, it's going to be compressed. So what kind of numbers do you think cause the graph to stretch?
Anything above 1?
Yeah, so anything,
Above or below 1?
so here's 0, here's 1, here's -1. So things will stretch anywhere in here,
And then from -1 and beyond.
and anything here, you'll get a stretch. So you will also get a flip if it's negative, but you'll get a stretch. And what's going to happen between -1 and 1?
Gonna shrink.
Yeah, that's going to compress it. So a number like 0.5, 0.7, -2/3, anything that's between -1 and 1 will cause the graph to compress. Anything in the green causes it to stretch. All right, so let's say that I want to know, let's try these 3, the amplitude. If I want to know the amplitude, first of all, what kind of number did we say amplitude always is? It's always positive. All we have to do to find the amplitude is do something to that number that I just circled. To find the amplitude, take the absolute value of the number in front. Okay, do we take the absolute value when we're graphing it? No. The negative causes something to happen. It causes a flip. That's very important when we're graphing. But when you're just finding amplitude, flipping doesn't matter at all. Okay, because if you have that, and then you take this, those two graphs have exactly the same amplitude, even though one of them is flipped. So when all we want is the amplitude, we can ignore the negative. But you cannot ignore the negative when you are graphing. Okay? I don't know how to say that any clearer. The negative is very important when you're sketching. Okay, so let's look at the first one. If I said to you, what is the amplitude of this one I just put a blue box around? 3. Yep. What if I asked, what's the amplitude of the one with the green box?
-2?
2. Yep, amplitude is 2. And the one in the red box? A half. What about the amplitude of the one in the red box now?
Half.
Still a half. Yep. Does the negative change the picture?
It will flip it.
It will flip it. But does that affect the amplitude? No. Nope. Okay. So amplitude, we already said that. Amplitude's always positive. All right. So I showed you on a number line when it stretches and compresses. This is exactly the same thing in words. Any number that has an absolute value bigger than 1 causes it to stretch. 1. Well, if it was exactly 1, it wouldn't stretch or compress at all. 2, stretch. 3.7, stretch. 3/2, that's a stretch. -4, that's a stretch. Okay. Things that would compress it, 0.7, 2/3, -1/2. Those would all compress it. And the stretching and compressing is always going to be on the y-axis today. So if it's going to stretch and compress along the y-axis, that pretty much answers this question. But if you had a graph like this, and then you had a graph that was stretched, compare this point to where it was originally. What part of the coordinate would have to change?
The y.
Yeah, the y. Because when it stretches, it's moving up, or it could be moving down. It depends. But it's the y. If the y coordinate, or the y part is changing, what part stays the same?
The x.
The x. Yep. So that y part is changing. The x's are not. Okay. When the x's don't change, it's a lot easier to do the problem. Because the x's are all the fractions with pi. So that means every problem we do today, here's the answer for the x's. 0, pi over 2, pi, 3 pi over 2, 2 pi. Those are the answers for your x's in every single problem we do today. Not every problem that's on the test, because that didn't work yesterday, but today it does. Okay, so x's are going to stay the same, which means what's changing again?
The y.
The y's. Think about the numbers in the y column. What are the numbers in the y column for sine?
Say 1, 0, -1, 0, 1.
So 1, 0, -1, 0, 1, that's for cosine.
Oh, so it's 0, -1. Wait. 1,
0, 1.
0,
Yeah.
-1, 0.
Okay. The only numbers that you're going to have to work with today are 3 different numbers. A 1, a -1, and a 0. That means the arithmetic is going to be very easy. So in this problem, to find the new y values, all you have to do is take the old y values, whether sine or cosine, depends on which one you're doing, and multiply the old y values by the number that's in front.
Wait, why do we have to change the y values?
Because it's moving up and down.
Because it's stretching up and down.
Ah.
Yeah. So you multiply the old y values by the number in front. Notice I did not put absolute value of the number. If the number is a negative, use the negative. If it's positive, well, use it as a positive. Multiply the old y values by whatever number you see right in the front. Do not take the absolute value. Okay, because if you take the absolute value and there was a negative there, you just wiped out the flip. And now it's wrong. Okay, so any question on the 2 steps?
This is for which part?
This is for a vertical stretch.
Oh, okay.
This is when we're changing the height, changing the amplitude. So you can call it a vertical stretch.
This would be like solving them.
No, this would be like sketching.
Okay.
Yeah, this would be for
What's gonna help
sketching.
us make the graph?
What's that?
This is what's gonna help us make the table.
Yes.
And the 1, 0, -1, that's cosine?
1, 0, -1, 0, 1 is cosine.
0. Can you do that? Okay.
Okay, so let's graph that. But first question I want to ask, because you'll have some like this on the test, what is the amplitude? And then you'll just give me a number.
3.
Yep. So if it says, what is the amplitude, you would say 3.
And it will always be that number?
Well, what would the amplitude be now?
Okay.
3. So no, it's not always the number that's in front. It's the absolute value of the number. Yep. But we're not going to do a negative right now. Okay, so y equals 3 cosine x. Okay, so first 2 questions you should always ask. What are you doing? What operation? And where are you doing it? What operation are we doing this time?
Cosine?
So that's the trig function, but what arithmetic are we doing?
You're multiplying?
Multiplying, yes. So multiplying is always a what? This is always a stretch. Okay, since we're multiplying by 3, we know it's a stretch. And then where are we doing it? Inside or outside?
Outside.
Outside. Inside would be inside those parentheses. It's not inside the parentheses. So we're multiplying, which means it's a stretch. We're multiplying on the outside. Outside is always vertical. That's what makes this a vertical and a stretch. It's a vertical stretch. Okay. When we do a vertical stretch, which column here stays the same? X. Think about if you took a graph and you stretch it. This point goes up to here. It did not move left to right when it did that. It moved up and down. So x's stay the same. What are my original x's for cosine?
0, pi over 2, pi, 3 pi over 2, 2 pi.
Yep. Original x's for sine and cosine are the same. Okay, so we're going to put all our answers in this table. Off to the side, I'm going to put my original values. What are my original y's for cosine?
1, 0, negative 1, 0, 1.
Okay, now we need to modify all those values. What are we going to do to all these values?
Multiply by 3.
Multiply them all by 3. And that's what goes in your table. Okay. So what are going to be the y values?
3, 0, negative 3, 0, 3.
3, 0, and 3. So that's how you do your table. Okay, 1 point for each x and y you get right. So the point, it's going to be 10 points for that table. All right, any question on the table? Okay, now, the problem with a vertical stretch is they can get very big, right? If you stretch something 30 times as much, I don't want to have to draw it 30 times as big. I might not even have that much room. So what I'm going to do is when I draw it, I'm going to change my scale. What is the highest y value that I need? 3, and the lowest? Negative 3. So what I'm going to do then is I am going to go by 3's on my y-axis. Now for my x's, they're always going to be the same for every problem we do today. 0, pi over 2, pi, 3 pi over 2, 2 pi. And that's labeling those tick marks. Make sure you always put 0 on the axis. The axis cannot be anything other than a 0. I've seen some people try to do that. All right, so let's graph our points. So 0, 3. Pi over 2, we're at 0. When we're at pi, we should be at what number? Negative 3. 3 pi over 2. Back to 0. And 2 pi.
3.
Back to 3. On the homework, it's a little easier because it's got the dots on it, so you can kind of see where it's going. And there's your sketch. Okay. Any question on the sketch? All right. Now, because I'm going to change my scale for every problem, if I had to graph y equals 20 cosine x, my picture would look just like that. The only thing I would do is I would make that a 20, and I would make that a negative 20. So by changing my scale, I can basically draw the same picture every time. And I don't have to draw it 20 times bigger. Okay. But the downside to that is that every picture is going to look the same today.
Awesome. That's very helpful.
Okay. Any question on that?
No.
Okay, so that's a vertical stretch. If that was a sound, so if you had this wave, tried to draw it as good as I could, and we took that and stretched it. Can I stretch that? Let's see. How do you think
High pitched.
the sound in red would compare to the sound in black?
The red one would be higher pitched than the black one.
I think the red one would be a higher pitch. Okay. Any other thought what the difference would be?
It could be a lower pitch.
Okay, so it's either going to change the pitch, or what else could it change?
The frequency of it?
So the frequency is the pitch.
Okay.
Yeah. But what else can you change about a sound besides
How
the
loud it
frequency?
is?
How loud it is. Yep. So let's see which one it is.
Do you have like a machine?
Yeah, I got some.
Yes.
Okay, so I can't make the graph any bigger, that's what you can see on the screen right there. And if I take and do that, that's a compression. And if I do that, that is a stretch. And if you read the name of the slider that I'm using, it pretty much tells you it's the what?
Vertical right and left. Volume.
Amplitude.
Volume. Yeah, it is volume.
So it'll get louder if it's bigger?
Yep.
Is that it?
So that's what happens if you compress it. Okay, I compressed it enough, you can't hear it right now. Start stretching. So stretching and compressing vertically is a change in volume. Okay, technically, it's a change in intensity, but the way we perceive intensity of a sound is volume. If this represented a light wave, which is another kind of wave, light can't get louder or quieter. It can get brighter. So the change in intensity for a light wave, it would be brighter or darker.
Is like doing this to it, like if you were to stretch it this way, would that make it higher pitched or lower pitched?
Yes. So stretching and compressing horizontally would change frequency, which is pitch. We'll talk about that one tomorrow. Yep. All right. Now let's try this one. Okay. So on the test, again, they're all going to be mixed together. Okay. So you're going to have to figure out what kind of transformation it is. Okay. First thing is, what type of arithmetic are we doing here?
Squishing it.
Yeah, so the arithmetic, your choices are either the add, subtract, that's one choice, or multiply. So this is multiply. And where are we doing it? Inside or outside?
Outside.
So when you
Why don't you draw the parentheses anymore?
you can put them, you don't need them.
Okay.
It's up to you. Yeah. It's kind of like on the calculator, if I do, get out of here. If I do like sine of 10, or I do sine of 10 and I put the parenthesis at the end,
Yeah.
it doesn't really matter. Okay, so multiplying means it's a
Stretch.
stretch. Outside means it's a, what direction?
Horizontal.
Vertical.
Oh.
Outside is always vertical. Inside is horizontal. That's why yesterday when we added or subtracted inside, it was horizontal
I get it.
shift. Okay, so what's going to stay the same?
X.
X's. What are my X's for sine?
The same as cosine. So 0, pi over 2 pi, 3 pi over 2, 2 pi.
pi over 2, 2 pi. Okay, so put those there. So we get 5 points for those x's. What are my original y values for sine?
0, 1, 0, negative 1, 0.
Okay. Now we're going to take all the original y values and do what?
Times it by 0.5.
Yep, times them all by 0.5 or 1/2. Okay, so take half of all your y values.
So 0.5, negative 0.5, 0.1,
0.5. What did you say for this one?
negative 1.5? No.
0, 1, whoops. 0, 1, 0, negative 1, 0. I think I wrote it.
0.
So that's 0
Negative
Negative
0.5.
0.5.
And then 0.
and 0. Yep. So those are your y values. Okay, make sure you copy the originals right. I don't know why I had them off. All right, questions on the table? All right, so now we're going to sketch it. We don't have to change the scale this time. I mean, we're only going to 0.5 and negative 0.5, so if we want to call that 1, negative 1, there's 0.5, and there's negative 0.5. So we can just do it like that. Okay, so where is my first point?
0.
0, 0. And
then
then
0.5.
these I need labeled.
Do you need those to label those?
Yes. If you don't label them, what do your tick marks always go by?
1.
Right. This would be 0, 1, 2, 3, 4, 5. And we're not going by ones on the x-axis. Okay, so we got 0, 0. What's the next one?
0.5.
Pi over 2 comma
0.5.
0.5.
And then 0.
0.
And then negative 0.5.
And then negative 0.5.
And then 0.
And back to the 0. Yes. Mr. Hager? Sure. You're welcome. Bye-bye. Will, Mr. Peary needs to see you for a minute. So just sign up.
What'd you get?
Okay, so we do our sketch, graph it, and that's it. Any questions on the sketch?
No.
Are you giving us another worksheet for homework?
Yeah. Yep.
Is there going to be a worksheet tomorrow too?
Yes. Yep. Okay, so we've seen a stretch that was 3 cosine x. We've seen a compression that was the 0.5 cosine x. What's going to happen in that one?
It's going to be short.
It's gonna stay the same.
Oh,
It's not going to stretch or compress, but the graph won't be the same.
It's gonna flip.
It's going to flip. So what number is really in front of that cosine x? What number?
A negative 1, but
Right. It's like having a negative 1. So effectively, because it's a 1, it doesn't cause any change in the amplitude. But because it's a negative, it causes a flip. Okay? We're going to do this problem just like we did the last two. Okay. What type of arithmetic are we doing?
multiplication.
Multiplication means we're doing some kind of stretch. Where is it? Inside the parentheses or outside?
Outside.
It's outside. Outside means vertical. Multiplication means stretch. It's a vertical stretch. All right. So which column stays the same?
X.
X's.
And
Okay. Hopefully by now we start to know those. Okay. What are my original y values for cosine?
1, 0, negative 1, 0, 1.
Okay. 1, 0, negative 1, 0, 1. And what are we going to do to all
Multiply
of them?
by negative 1.
Yep, we're going to multiply them all by negative 1. So what are my new y values going to be?
Negative 1, 0, 1, 0, negative 1.
Yep. So there's your table for negative cosine x. Any questions on the table?
No.
All right, so now the cosine function normally, when we draw it, it looks something like that. This one is going to look more like that. It's going to flip. All right, so let's label everything. We got 0, -1, 1. We got our 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay, and we're going to start at 0, -1. Then we're going to go pi over 2, 0. Pi, we're up at 1. Then we're going to come back down to 0. We're going to go back to -1. And there's your sketch. Okay, so in terms of the wave, what you're basically sketching is this middle section right there. That's what it should roughly look. Okay, any question on that transformation? That's the vertical stretch or amplitude change.
Can you just go up a little bit? Just so I can see the chart.
What is, if I did ask, what's the amplitude in this problem?
One. Or 1.
1. Amplitude of that is 1. What's the amplitude of this one?
1/2.
1/2. And we did the first one, that was 3. What if I got rid of the negative? What would the amplitude be?
1.
Still be 1. Yep. All right. So last transformation we're going to look at for today is still vertical, which means it's going to be where? Inside the parentheses or outside?
Outside.
It's going to be outside, but it's not going to be a stretch.
It's going to be division.
It's going to be a shift. What operation do we use when we have shifting?
Division. Subtraction.
Well, we did shifting yesterday.
Subtraction and addition.
Subtraction or addition. Yep. Now, we added and subtracted yesterday. What's the difference between the adding and subtracting that I'm doing here and what I did
One
yesterday?
of them's inside the parentheses, one side is out.
Right, this is outside. You can put parentheses, this doesn't matter. Right? It's outside the parentheses. Okay? The only way that it could be the kind of problem we did yesterday is if it was like this. You have to have the letter and the number together in parentheses. If you don't have exactly what you see right there, then it's outside the parentheses. Even if there's no parentheses there, it's still, if they were there, it would be outside. Okay. So I want you to get used to seeing it with parentheses or without. It means the same thing. All right, now, question. If we do, let's say, a plus, like a sine x, and then a sine x plus 3. We know it's going to be a vertical shift. But which way do you think a plus 3 would move it? Up or down?
Up.
Up. All right, let's see. So there's the original. And a plus 3 does move it up 3. So today the transformations are not backwards. Okay, yesterday a plus moved it to the left and a minus moved it to the right. That's the opposite of what you would normally think to do. But in this case, plus moves it up. How about a minus 3?
Down.
That's going to move it down. Okay, there's the original. Here's minus 3. It moved it down 3. Okay, in terms of sound, I really don't know of a connection you can do between those two. It's not a change in volume, a change in pitch. I don't really think this applies to sound. But. Okay. So based on what we just did, what kind of numbers do you think are going to shift it up in general?
Positive.
Positive and down?
Negative.
Negative. Yep. So a vertical shift will move the function up if you're adding and down if you're subtracting. Positive numbers move it up. A negative number will move it down. So let's take that wave. Let's make a copy of it. And let's say we shifted it like that. Okay, this point right here went up to this point right there. What part of the coordinate would change to make it go from here to here? It would be the y again. Yep. So anytime you're doing a vertical transformation, it is the y that changes. Horizontal transformation, it's the x. All right, so the y is going to change again, just like the last one. If the y changes, that means what stays the same?
The x.
The x. Yep. So now we want to get ready to figure out how do we make our table, which is going to help us with the sketch. Okay, first thing, x's stay the same. What are my original x's for sine or cosine? Doesn't matter.
Hey, what?
What are my original x's for sine or cosine?
0, pi over 2, pi, 3 pi over 2, 2 pi.
Yep. And those are going to be the x's for every problem in tonight's homework. All right, so x's stay the same. All the y's are going to change. The number that I represent for the shift, I just called it d. Okay, that's the number that you're adding or subtracting on the end. Whatever that number is, you are going to add or subtract that to all the original y values. You don't do the opposite. So this is where people start to mix it up. They remember from yesterday when you saw plus in parentheses, we did a minus. And they think, oh, you just always do the opposite. No, not here. If you have a plus 5 on the end, you're going to do a plus 5 to all your y values. If you've got a minus 6 on the end, you're going to do a minus 6 to all your x values, all your y values. So you don't do the opposite. Yesterday you did, today you don't.
So horizontally, you do the opposite.
Yes.
Vertical, it stays the same.
Yes. Yep. Horizontal is always the opposite. Vertical stays the same. Okay. Any questions before we do some examples of those two steps? All right. So let's try a couple shifts. All right, so first thing, make sure you look at the equation. Ask yourself, what operation are you doing? That'll tell you if it's a shift or a stretch. And then where is it? Inside or outside? Okay. What operation is this one?
Addition.
This is addition. And
It's a stretch.
addition or subtraction is always a
Shift. Sorry.
shift.
And it's on the outside.
And it's on the
So it's
outside.
vertical.
Outside always means vertical. So this is a vertical and it's a shift. Okay, there's only 4 different options. There's a vertical and a shift, a vertical and a stretch, horizontal shift, horizontal stretch. Okay, those are the 4. All right. Since we are shifting vertically, which column stays the same?
X.
The x's. Yep.
And it's 0, pi over 2 pi, 3 pi over 2, 2 pi.
Okay, and remember, don't forget why we picked those. We picked these because they're all nicely spaced. If you did it in degrees, that's 0, 90, 180, 270, 360. It gives you all the nice points you need to make a sketch. That's why we picked those.
Now, does it have to be in radians on the test?
Yes, the test will ask for everything in radians.
Okay.
Yep. That's why I've been doing them in radians. Okay, let's make our box where we're going to put the answers. Somebody tell me my original y values for
0,
sine.
1, 0, negative 1, 0. And then you add 2.
Right. We don't do the opposite. You're going to do a plus 2. To all your y values. Okay, what's that going to give me for new y values?
2, 3, 2, negative 3, 2.
2, 3, 2,
Oh, sorry, 1.
1. Yep. And the last one? 2. So 2, 3, 2, 1, 2. And that's it. So I told you the arithmetic's a lot easier today because we don't have to work with x. Okay, yesterday we had to work with x. Tomorrow we're going to have to work with x again. But today is y. So 2 transformations you have to work with x. 2 of them you have to work with y. You've now done both of them with y. Okay. Questions on the table? All right, let's make our sketch. What's the highest we need to go for our y's?
3.
3. The lowest is
1.
1. So I would just start at 0. So let's go 0. That's fine. We just need to go up to 3. Okay, x's. Okay, so we got everything labeled. What is my first x value?
2. 0.
0,
2.
2. So that's my first one. Next one?
Negative pi over 2, 3.
Pi over 2. We're up at 3. Yep.
Pi 2.
Pi, boom. Back to 2.
3 pi over 2, 1.
So
2
right
pi
there.
2.
2 pi, back at 2. And there's your sketch. Okay. Any question on the sketch? What if I said, what's the amplitude of that?
3. Sorry. 2. 1.
1. Remember, the amplitude is the height if you put a center line in. It's the distance that you move. It's even better if you draw your center line horizontal. The amplitude is the distance off that center line. It's only 1 unit above and 1 unit below. So the amplitude there is 1. Okay. What if I said, what's the highest value that it ever hits?
3.
3. That's a different question. Any question on the difference between the highest value it hits and the amplitude? They could be the same. In this one, they're not, though. Right? They're different. All right, let's try this one. So y equals cosine x minus 5. Okay, first thing you want to ask yourself is what? Right, are we inside or are we outside? Outside. So outside tells you what?
Vertical.
Tells me it's vertical. That's all it tells me.
And it's subtraction. So
And it's subtraction, so that's a shift. Outside is vertical, subtraction is a shift. That means this is a vertical shift. Can we be a little more specific and tell me which way it's going to shift?
Down.
It's down. Yeah, it's a shift down. And it's going to go down how many?
5.
5. Yep. Okay, if we shift down 5, what column is not affected?
The x.
The x's. And what are my x's?
Your x's
0
are
pi over 2 pi 3 pi over 2 2 pi.
what she said.
3 pi over 2, 2 pi. And can someone else give me my original y values for
0,
cosine?
1, 0,
That's
-1.
no, that's the wrong one.
I thought you said they were the same for both.
Not y.
The x's are, but the y's are
okay.
not.
1, 0, -1, 0, 1.
Yep. So unfortunately, if you copy the wrong y values down, then this half of the table is going to be wrong, and you're probably going to get the sketch wrong because you have the wrong y values. All right. So just make sure we get the correct ones. Now, take the y values and do what?
Subtract them.
Subtract
5.
5. Don't do the opposite. So my first y value is going to be
Negative 4.
the second one.
Negative 5.
Third
Negative
one?
6. Negative 5. Negative 4.
Negative 4. Yeah. When you do your cosine table, one thing that should always happen is the numbers are the same forwards and backwards. -4, -5, -6, -5, -4. Yep, that always should happen. So once you do the first three, then you really could just copy those other two numbers to get the last two. Okay, any questions on the table? All right. So what's the lowest we need to go here for the y's?
-6.
And the highest is
Negative 4.
-4. So our entire graph is going to be below the x-axis. Okay, because I know my graph is going to be down in there somewhere, I can put my labels right here, and that's not a problem. Generally, I like to avoid having to draw through the label when you make the picture. Okay, what's my first coordinate?
0, -4.
0. Whoops, I put all those off by 1, sorry. I wasn't looking. It should be right there. The axis is always 0. Okay. So 0, -4. All right. What's my next one?
Pi over 2, -5.
Okay, pi over 2, we're at -5.
Then pi -6.
Pi -6.
3 pi over 2, -5.
Back to -5.
2 pi -4.
2 pi, back at -4. Okay, and make your switch. Okay, any question on that? All right, so that's the vertical shift. Okay, so that's both transformations on the y-axis, stretch and shift. So we've done everything on the y. We did the shift on the x. The only thing we have left is the stretching on the x. And that's the last one we'll look at tomorrow. So any questions on that one? Okay. So homework, again, tonight will be a worksheet. And yeah, I can print that out.
Can you print that out for me, please?
You just kind of said that.
Well, I was just making sure.
Yeah, I'll print it out for everybody.
Thank you.
Thank you, Mr. Hager.
We appreciate you.
You're the man.